Welcome to the SolidCAM UK Technology Centre. Inside there we have over 6,000 square feet of office space and shop floor space. Within the centre itself we have 3 CNCs, a 3-axis machine, we have a 5-axis machine, and we have a mill turn, all supplied by Romy CNC. The idea of the Technology Centre is that we can deliver cutting trials. We can do live events, we can showcase our eye machining products, and we can literally show off the software to its best and fullest advantages, which is obviously the biggest benefit to the end user. Inside there we also have our training facility, we have post-processor writing, we have support going on, so we have everything encompassing what SolidCAM is about for the UK. So we're now going to go inside and have a look at what we've got in more detail. Enjoy.
Thanks, Gordon. So we're now inside the Technology Centre, where we've got a few machines in here, and we use these for running live cutting seminars. You can see the Romy D1000 behind me is currently running on a component doing some eye machining. Now, just to explain a little bit about eye machining, you can see the component here in SolidCAM, and first what we want to do is we want to rough out the centre bore. Now we're going to use eye machining for this, which is our high feed roughing strategy. Now I'm going to select the tool. Now with eye machining we have to give all the data that is required. So we need to tell the tool, or we need to tell SolidCAM what angle the tool is, the grade of carbide, the material we're cutting, and it already knows all about the machine parameters like the maximum feed rates from our post-processor. Now we can see that eye machining has calculated the depth of cut for us here. It's green, and you can see the speeds and feeds have been calculated also. Now this is the machining level, so we can reduce or increase this based upon the rigidity of our setup. You can see all the speeds and feeds moved in conjunction with each other. Now eye machining aims to take all the vibration out of the component. It's also rapid material removal as well. So you can see here we start in the centre and we're moving out. So we're going large depth of cut, small step over, and a high feed rate. So you can see there we're taking out all of that material out of the centre in 2 depths of cut, 23mm depth of cut at a time. Now if we come back to SolidCAM, come out of the simulation, and we have a look at machining around the outside as well. Again, we're going to use eye machining for this. The geometry that we select, nice and easy, we select the outside of the component. We're using the same tool, and in the Technology Wizard, again, it's selected a depth of cut 41.7mm, and we're nice and green. So we're going to calculate this now, and this will produce our eye machining, our roughing toolpath, all the way around the outside of the component. You can see that cutting there live down at the bottom left-hand corner. So that is actual speed as well on the machine. You can see the chips peeling away nicely and being thrown away from the component as well. That is a 41.7mm depth of cut, running at around about 10% step over on EN24T. Now again, just continuing on with eye machining, this is another component here. This is actually on our other machine, our Romy DCM 5-axis machine. We'll come to talking about that in a little while. However, you can see here again, this is eye machining. This is 3D eye machining now. So this is cutting a 3D component rather than just the 2D pockets you've just seen. So this is going to leave us with the rough shape of the component, leaving a cusp all over the job or component itself. You can see here it's got a depth of cut as it keeps going down, and you can see it's leaving that 3D shape behind, and we're now on the next depth of cut as we cut all the way around that component. Again, you can see the chips coming off nicely. We have a high feed across the back of the job there where it's not cutting any material. So instead of it lifting and doing a rapid move and then dropping back down, instead we stay a safe distance away from the component or away from the material and do a high feed move. Now you can see the same component just from some different angles. You can see on the right hand side there we've got the table tipped over at an angle. So we can use iMachining in 3+2, and in the centre there you can see some slow motion cutting of iMachining. Now moving on, again, SolidCAM has lots of different features and lots of different operations to machine every component. One of which is engraving. You can see there's a lot of engraving on the top of this component. I just want to show you how easy it is to select the geometry to machine this engraving. So I've selected the sketch from SolidWorks that has been used to create that engraving. This will select all of those chains for me, and then go and select the tool that I want to use, in this case a 1.5mm ball nose, and I select the depth of the engraving, which is a 0.1mm depth of cut, and I want the tool to be on the center line of the text. So again, we're just going to show this in simulation, and you can see there again against the live cutting down at the bottom left hand side there, we have our engraving on that component. So again, lots of different operations inside SolidCAM. Over there we've covered some 2.5D milling, some engraving, some iMachining on there as well, and there are lots more in there. Now what we're going to do now is I'm going to walk you over to the 5-axis machine. I'm going to talk a little bit about the 5-axis simultaneous operations we have in SolidCAM, and some of the other features we can use as well, like barrel cutting, etc. And as you can see, the machine is running. So we're running some 5-axis simultaneous toolpath on this machine at the moment. So this is the 5-axis simultaneous machine from Romy, and I'm just going to talk to you about some of the operations we can do inside SolidCAM regarding 5-axis. So you can see here this component inside SolidCAM. This is the component that's on the machine at the moment, and we need to finish all of this component using simultaneous 5-axis. You can see the wings are 3D, and what we're going to use for this is we're going to use a barrel tool. So again, 5-axis simultaneous inside SolidCAM. The selections are nice and easy. In this case I am morphing between two curves, so I'm selecting the face that I want to machine, I select the end curve, and I select the edge at the bottom of the wing. Toolpath parameters, we are doing a 2.5mm step down with the barrel tool. And again, if we have a look at the barrel tool, you can see this is a 10mm barrel with a 100mm profile radius on the outer. And we've also got 1.5mm corner radius at the bottom, so making this a 3mm ball as well at the bottom. So if we simulate this, you can see the barrel tool cutting that wing or finishing that wing. You can see it there live on the machine. So again, 2.5mm step down on that tool gives us a nice finish compared to what you would get with a ball nose. So moving on, using that barrel again, the barrel cutter doesn't always have to be for 3D faces. In this case I'm using it to finish the floor due to access. So I cannot get a flat tool in there from above. and I cannot get one in from the side due to the restrictions with the table being in the way. So in this case I've used the barrel tool to actually finish a flat face on here. And what I also want to do is I don't want to use the same contact point with the barrel tool as we go down that face. We don't want to wear the barrel tool out in one place. We want to alter the contact angle as it goes down that face there. So again, the selection in this case is the face that I want to machine, and then we follow in the curve at the bottom of that face. 2.3mm step down in this case, and here is where we set the contact point. So we set the contact point to barrel section, and I've set it to a line parameter of between 30 and 0%. So it will start at the 30% mark up the tool, and then it will, as it goes down, it will rock itself down to the 0 degree point. So the tip of the barrel, not the tip of the tool itself, but just the bottom of the barrel shape, so just above the corner radius that's on the component. So again, if I just show you this in the simulation in the host CAD first of all, you can see that is my first contact point there, 30% up the tool. And as we go down this face, the contact point will continue to change and come down to its end position. You can see it there running on the machine. So that is the component being cut. And you can see there, simulation have slowed that down. You can see the contact point now further down that barrel shape, so that we don't wear the barrel out all in one place. So again, we are time saving using the barrel instead of a ball, and we're also using a barrel in this instance due to an access problem. So again, SolidCAM can overcome these issues by using the correct tooling, and we can use these tools using the simultaneous operations that we have. Now again, I'm using the same method here to finish the front face of this plinth, and again I'm altering the contact angle as I go down the face. You'll be able to see there on the live cutting that the B-axis continues to tilt over as we go down that face and finish it completely. So we get a nice clean finish on that face, and again using that large step down and altering the contact angles. So SolidCAM 5-axis is a very powerful tool inside the software. Again, there's lots of features in there. We're using all sorts of different types of tools. We do support all of the barrel tool shapes as well. Now something else inside SolidCAM as well is mirror machining. So you can see here I've done one of the wings, so I finished one wing with that barrel tool. I now also need to finish the other wing. So in exactly the same manner, I want to produce the other wing. So I'm going to use the mirror option, and I'm going to tell it to create a new operation. We are mirroring about the ZX, and I want to use the same coordinate system for my mirrored toolpath. You see there, once I click OK, it will calculate that toolpath and it will mirror the toolpath over to the other side. So that's mirror machining. We've also got translate in there as well, and rotate, so we can create complex shapes. We can also create left hand and right hand components quite quickly, quite easily. So that's the shop floor, that's our machines we've got out here, and we're next going to go and have a look inside our meeting room through here. So this is now the conference and meeting room. This is where we can hold meetings, and we can also do presentations and customer demonstrations when we're not doing them at our customer's facility. Now you can see on the screen here, we're going to have a look at another area of SolidCAM, which is the Swiss and sliding head section of SolidCAM. So on here, you can see the component is being set up, and we've created the first datum position, and SolidCAM will automatically create our second datum position for the back spindle. This is the toolkit. So the toolkit is a very useful tool inside SolidCAM. We can quickly and easily put our tools in the correct positions, correct stations, and the correct tooling gang inside SolidCAM. Now this toolkit is not specific to the sliding head. It's widely used throughout SolidCAM on any machine, whether it be milling or turning. So you can see here tools are being set up and created, and they're being laid out as they would be on the machine. This gives full and accurate collision detection. In this case, we're adding a tool to the lower turret. We're also putting on a multi-tool holder. So this holder can hold 3 tools. One holder in one station, and we're adding 3 tools to this so that we can use them in SolidCAM and on the machine. So you can see we've added a spot drill, we've added a drill, and then we change the connector to the second position, and then we add a boring bar as well to the lower. So we've loaded that tooling holder up with the 3 tools needed. And we've also got the ability to add tools to the predefined gang stations as well. So you can see there an end mill has been put on the lower gang, and we now put an end mill on the B-axis on there, and we're changing the mounting position to the center as well. So again, quickly and easily setting up the tools ready to use on this job. So now we can see the tools being used. Again, we'll use SolidCAM just as we would in any of the other operations, whether we're milling or turning. We'll go and select the tool. So again, we select the 6mm end mill in this case, and we create the toolpath on the front of this component to machine that front shape. And again, another area of the turning module inside SolidCAM is the threading operation. So again, SolidCAM can do full threading, thread turning or thread milling. In this case we are thread turning. We select the tool, we select the geometry, and then we can either use the thread standards table, or we can create a custom thread by filling in the values ourselves, so filling in the minor diameter in this case, and then we'll set the approach types and the approach points, and we'll also extend the thread at the beginning and the end, so we get a nice run into the thread and a nice run out of the thread. You can see there as well we've got the different thread patterns for doing flanking, etc. So again, here's where we're extending the thread so that we can lead in and lead out of that thread nicely without bumping any of the material. So we'll calculate this toolpath, and again we've got full simulation of this. So if we look in our turning simulation, for instance, you can see the thread is fully simulated. If we play this step by step, you can see each cut taking place, and you can see the thread being left on that component. Now looking at another area, the setup of these complicated mill turn machines and sliding heads. So you can see here we have dynamic setup. We can set the component stick out, and we can visually see that as well as we move the position. We set the back spindle component stick out up as well. So again, we can move that component into position, and we can visually see that we've got this correct before we move on. And this can be done at any point. You can see we've done this after we've done some programming. Now we've also got machine control operations as well that are built into our post processors. So particularly useful here in the sliding head machine. You can see we've got specific functions to add for the different axis patterns, for instance. And we've also got the functions for doing the part off and transfers. So in this case, at the moment, what we're doing here is we are pre-positioning our parting off tool. So you can see pre-position a parting off tool into position. So that's our first machine control operation. What we will then do is we will then position our back spindle, so back spindle approach. And again, this is all dynamic and visual, so we can see where the back spindle will be by typing in our figures in the operation. Now these are fully customizable when we write the post processors. So again, now we're doing the cut-off operation. So now we've positioned the back spindle, we are ready to cut the part off and transfer it to the back spindle. So again, the geometry that we're selecting here is the back line of that stock. So we want to part it off down that back line there, leaving a little bit of stock on the front of the job, or the back of the job in this case. So again, once we've set out all our parameters, we can see we have our cut-off operation. Now if we move into full machine simulation, you can see we've added a few different views here. So we can see the full machine top left, the main spindle on the top right, the back spindle bottom left, and then just from above at the bottom right. Now you can see this is not synchronized at the moment. What's happening at the moment is we have machined everything on the main spindle and anything on the back spindle. Here we can see we're now synchronizing our components. So we've opened up the channel synchronization. Here we can see we've got all the different axis patterns and superimposition. We can lay our toolpaths out now how we need them. SolidCAM will tell us if there's any collisions or any errors. You can see here now we have both spindles working at the same time in simulation and the live cutting down at the bottom right hand of the screen there as well. So you can see we're now fully synchronized and optimized. This is how we want the machine to work, and we're fully collision checking the component at the same time. So again, the four different views are handy. We've now switched to one full view, so we can show the B-axis machining working. So again, we're just indexing round. We've indexed the B-axis, so we can use it indexially, and we can also use it simultaneously, just like this here. So we're producing a chamfer on the top of those holes simultaneously with that B-axis. So once we're happy with the simulation, we're happy with how we've synchronized our channels, we can now output the code and view it in our Sync Master. So the Sync Master will show us where all our synchronization points are, and it will neatly lay out the code so that we can see what's happening at what points in time. So that was a little tour of our technology centre. Please do get in touch if you need any further details. You can contact us using our email address, the SolidCAM website, or our phone number on screen there.